This conference will now be recorded.
Okay, let's start. Hope it's audible to everyone. Right. Okay, so in the last class, we have started with what structures. We understood how to declare the structure. Okay, and we have seen another syntax for creating a structure based on existing structure. And we have seen how to copy the data between two similar structures and dissimilar structures. We understood the concept of what move and what move corresponding and the limitations of using what move corresponding. Okay, right. So now let us see in continuation to that. Let us see. These are all very simple concepts. Nested structures. Okay, nested structures. So just like we have nested if. Nested if means what? If within the if block. Okay. Similarly, nested structure means a structure declared inside another structure. Okay, that is the meaning of what? Nested structure. So let's see how to declare the nested structure. One second. One second, please. Just hold on. Yeah. One second, please. Yeah. So I'll give the program name Z645 program 14. Type of program is executable program. I'll save it in what? Local object. Right. So what is our requirement? We need to declare what? Nested structure. Structure within the structure. Okay. So structure within the structure. So I'll say, how do we create a structure? Data. Okay. Begin of. Okay. Data begin of. Let me give the structure name as something EMP. Okay. Data begin of EMP. And I'll declare some fields here. Employee number type I. Then another field employee number of 20 type C. Okay, so within this EMP structure, okay, within this EMP structure, let me declare another structure. So I'll say begin of what? Department. Okay, so without closing the EMP structure, I'm trying to declare what? One more structure. Begin of department. I'll declare one more field, department number type I, then department name of something 20 type C. Then I'll close the department structure. End of what? Department. Okay. Then after closing this inner structure, Okay, after closing the inner structure, let me declare one more field, employee designation of 20, type C. Then close the main structure, end of what? EMP. So this department is nothing but what? Inner structure. Inner structure, because I am declaring this department structure within another structure. Okay, done. So when I save it, let me check the syntax errors. Control F2. Yeah, I don't have any syntax errors. Okay, so how much memory is allocated here? Yesterday we have seen that uh, for structures the memory allocation is what? Continuous, means all the fields are stored one after the other. So if you assume that this is the memory allocation, okay, there's a memory allocation. What is the first structure I declared here? One second. Yeah, what is the first field here? Employee number, type I. So in ABAP, integer occupies what? 4 bytes. So assume that if you assume starting address is 100, starting address location is 100, so 100 to 104 would be the employee number. Okay, 100 to 104 would be employee number. Okay, then employee name of 20, type C. Each character occupies 1 byte. 1 into 20 is what? 20 bytes. So this is employee name. Employee name. So 104 to how many bytes? 20 bytes. So 104 to 124 would be what? Employee name. Then we are declaring one inner structure. We are starting the declaration of an inner structure. What is that inner structure? A department. So assume that this is a memory allocated for your inner structure. Okay, something like this. And my inner structure contains how many fields? Two fields, department number and what? Department name. So assume that this is department number and this is department name. Okay, so this is a overall memory allocated for your inner structure. What is the inner structure here? Department is a inner structure. Okay, so what is this? A department number, type I. Again, integer I indicates what here? Integer. So integer occupies what? 4 bytes. So 124 to what? 124 to 128 would be what? Department number. Okay, 124 to 128 would be department number. Then again department name of 20, type C, 20 bytes. So 128 to 148, you assume what? Department name. Done. Then we are closing the inner structure, and as part of outer structure I declared one more field. What is that? Employee designation of 20, type C. Okay, which is what? Character of 20. So again another 20 bytes of memory would be allocated for the employee designation. So assume 148 to what? 168 is the memory allocated for what? Employee designation. Okay, so these two, okay, department number and department name are part of what? Department structure. And employee designation, employee name, they are part of what? Employee structure. Okay, so this is the overall memory allocated for your outer structure. What is that? Employee. Now the important thing here is how do we access this field? So inner structure means a structure within the a structure declared inside another structure. So now let me try to store some data, and already we have seen yesterday, once a structure is declared, the structure fields will be initialized to what? Default values. Employee number is integer, so integer by default contains 0. Employee name is what? Character, so it will contain what? Space. Department number again 0. Department name is character, again not space. Employee designation also what? Character, it contains what? Space. These are the current default values. Now let me assign some data. How do we access the structure fields? Structure name hyphen structure field. So I'll say emp hyphen employee number. Understood? Structure name hyphen structure field. Emp hyphen employee number equal to, I'll give some value, what? Some value 1. Then emp hyphen, what is the next field here? Emp hyphen employee name equal to, I'll say something Raju, something. Okay, so emp hyphen employee name equal to Raju, and then I want to set the value for what? Department number. Okay, department number is the field of which structure? Department structure. and department structure is declared inside what? EMP structure. So suppose, okay, when I do syntax check, as of now I don't have any errors. Now I'll try to say EMP hyphen department number equal to some value what? 10. I'm trying to assign department number value as what? 10. Let's see whether this is valid or not. When I do syntax check, yeah, I got an error here. I got a syntax error. What is the error here? The data object EMP has no component called as department number. Okay, whatever we declare inside the structure, they're nothing but what? Fields. Fields are nothing but what? Components. So it is saying that the data object EMP has no component called as department number, but there is a component called as what? Department. So department number field is not the direct field of department. It is part of, sorry, department number is not the direct field of what? EMP. It is a field of department, and department is declared inside what? EMP. So if I try to say like this, it is giving me what? Syntax error. So this is giving me what? So for your reference, I'm just giving a comment here, syntax error. So how do we access that? EMP hyphen department number equal to some value 10. So the main focus here is how do we access the inner structure fields? How do we access outer structure hyphen inner structure hyphen field name? Similarly, what is the other one? Department name. So I'll say department name equal to something sales. Then what is the other field here? Employee designation, which is a direct field of what? EMP. So I'll say EMP for employee designation equal to something manager. Am I clear? So this EMP is outer structure. Department is what? Inner structure. Okay, done. Now let me just print it. Right. I'll say EMP if an employee number, or let me give some text kind of thing. Employee number, done. Then EMP if an employee number. Then I'll say employee name, EMP hyphen employee name. Then what else? Department number. Department number. I'll say EMP hyphen department number. Then department name. What is that? EMP hyphen department name. Then employee what? Designation. I'll say designation. What is this? EMP hyphen. What is the field? Employee designation. Okay. So save it. Check no syntax error. Activate. When I execute this, yeah, I got the data. So I got all the fields one after the other. I want to print them in a new line. So what you have to do? Just say what? Slash. Right. So I'll just say slash here. Done. So save it. Check for the syntax error. Done. I got the data. It is not properly aligned. Okay. I want to do the proper alignment. So what I'll do is here for each of this label, for each of this text, I will reserve some width. How do we reserve the width? As part of the write statement, I'll say what? 20. Okay, what is the meaning of that? I am reserving some 20 spaces for this particular string. That is for this particular string variable. Okay, here also I'll give what? Same 20. So that everything will have what? 20 spaces. So that you'll get it proper aligned. 20. Done. Here also I'll say 20. Done. So let me check it now. Right. So I got something like this. Okay. Here also. Done. So I got employee number, department number, and these are characters. So already we know in ABAP numeric data types are what? Right justified. That's why in this space I'm getting this value in the right hand side. If you take these characters, we know that characters by default are what? Left justified. So this left justified and this is right justified. Done. So the main focus here is how do we declare the inner structure within the structure. Okay, and how do we access the inner structure fields? Outer structure hyphen inner structure hyphen field name. Okay, this is important. That's all. It's a very simple thing. Okay, done. Any questions in this part? Any questions? Right. Okay. So this is inner structure. Now let me go for including structures inside what? Other structures. Including structures inside other structures. Yeah, any questions? Anyone? Right. So including structures inside other structures. Done. So let me do it in the next program. I'll go back. One second. I'll save it in your folder. Done. So what is the requirement now? Including structure inside what? Other structures. Type of program as usual, executable program. Done. Okay. So here I'll say data begin of. Okay, data begin of department. I'll declare some fields, department number type I, and I'll declare another field, department name of 20 type C. I'll close the department. Okay, so this is the department structure I declared. So what happens here, on behalf of this structure declaration, some memory will be allocated. So assume that this is a department structure which has got what? Two fields, department number and this is department name. If you assume starting address as 100, integer occupies what? 4 bytes. So department number is integer, it occupies 4 bytes. Department name is character of 20, so 104 to 124. Okay, would be the memory allocated for what? Department name. This is the overall memory allocated for your department structure. Done. Now within the same example, I'll create another structure, data begin of what? EMP. I'll declare some fields, employee number type I. Okay, employee name of 20 type C. Now what I want is, in this EMP structure also, I want the same two fields, department number and what? Department name. So what I can do, I'll just declare this once again here. Okay, I'm declaring, I can declare. Okay, then let me declare another field here, employee designation of something 25 type C. Employee designation of 25 type C. Then also what? End of what? EMP. So I created what? Two different structures, department structure and what? EMP structure. So when I do syntax check, I don't have any errors. So what you have to understand here is, in the EMP structure also, again I declare the same fields, what? Department number and department name. It is allowing that, not an issue. But instead of doing like this, instead of redeclaring the fields once again, here in this case, we have only two fields I am declaring. But assume that here I am having some 10 fields. Okay, I want to use the same 10 fields in the EMP structure. I can declare those 10 fields once again. But instead of declaring the same fields again and again, what I can do is, instead of saying like this, okay, let me comment it, or okay, instead of redeclaring the fields, what I'll do, what is my agenda here, in the EMP structure also I want what? Same fields, department number and what? Department name. So instead of redeclaring them once again, okay, I can include them. How do we include? See here I'll say what? Include structure. Okay, include structure. Okay, include structure. What is the existing structure name here? Department. Okay, so what is the keyword I'm using here? Include structure department, let me say comma, but I'm getting some syntax error. Okay, let me check what is the error. Okay, include structure is a keyword here. So when I do syntax check, yeah, I got an error, unable to interpret what? Structure. Unable to interpret structure, possible causes of error, incorrect spelling or comma error. So this include structure is a what? It is a what? A new statement. So before we start using the new statement, we have to close the previous statement na? So what I have to do is I need to close this previous statement. How do you close it? Just you have to give what? Period. Understood? So I'm giving the period there. Then I'm saying include structure department. Once this is completed, once this statement is completed, you close that statement by using what? Period, that is dot. Then I need to close my main structure na EMP. So since I have ended the previous statement, again here you need to start with what? Data keyword. Again I need to start with what? Data keyword. Employee designation of 21. Am I clear? So, what I repeat once again, include structure is a keyword used for including a structure inside what? Another structure. As of now, what I am doing, I am including the local structure. I'm including the local structure. Local structure means what? A structure which is available within the same object, within the same program. But I have the option to include the global structure also. So whenever I say include structure, what happens? What I'm saying here, department na, SAP will check whether this structure is available in the current program. Yes, it is available. It will include that. Okay. Suppose I'll say include structure department 10. So what happens now? It will check whether this structure is available in the local program. If it is not available in the local program, it will check whether it is available in the database. Okay, so at this stage, we don't know how to interact with the database. If it is there in the database, fine, it will include. If it is not there in the database also, obviously it will give what? Syntax error. So what I'm trying to say is, by using include structure, I can include either the local structure or global structure. What do you mean by local structure? A structure declared within the same program. Global structure means which is available in the database. It can be accessed anywhere. But at this stage, we don't know how to create the structures in the database. So now when I do syntax check, see here, what is happening? I am getting an error. The field department 10 is what? Unknown, means it is not available locally, it is not available globally. When I say globally, in the database, that's why it is giving me what? Syntax error. Understood? So let me just close this. Include structure department. Am I clear? So what this include structure will do, it will include all the fields of the included structure in the current structure. Include structure will include all the fields of the included structure in the current structure. So what happens here? Yeah, what happens here? Already I declared the department structure. Now within the same program, I am trying to create what? One more structure. What is that? EMP structure. What is the first field here? Employee number. Okay, the first field is employee number. Next it is what? Employee name. And then you are saying what? Include structure department. So whatever the fields are there in the department structure will be included as it is in the current structure, that is in the EMP structure. Then what is the other last field here? Employee designation. So here, what are the field names now? The first field is employee number, this is employee name, and this is what? Department number, and this is department name, and this is employee designation. Again, if you assume starting address as 200, employee number is integer, so it occupies 4 bytes. Employee name I declared as character of 20, so 204 to 224. Then you are including what? Department structure. What is the first field in the department structure? Department name number, which is integer, so it occupies what? 4 bytes, so 224 to 228. Then again, department name of 20 type C, 228 to 248. Then again, employee designation of 25 type C. So 248 to something 273 would be what? employee designation. This is the overall memory allocated for what? EMP structure. So what is the advantage of this one here? Instead of redeclaring the fields once again, if you are interested to include, if you are interested to include all the fields of an existing structure inside another structure, I can do it in only one statement by using what? Include structure. Assume that department structure has got 10 fields, for example. Assume department structure has got 10 fields. Out of 10 fields, I want to use only 8 fields in the EMP structure. So at that time, we need to declare that 8 fields once again. I cannot say include structure. When do we go for include structure? When we are sure to use all the fields of an existing structure, then only we have to include that, include the whole structure. And this included structure can be either local or what? Global. And whenever we include, the fields of the included structure becomes part of what? Current structure. So when I say becomes part of current structure means, how do we access now? See, I'll say EMPF1 employee number equal to something 5. Then what? EMPF1 employee name equal to, I'll say some value. Then EMP hyphen, yeah, EMP hyphen, you are including the department structure na, which has got what? Two fields, department number and what? Department name. So they become part of what? EMP. Okay, they become part of EMP. So here I can directly access. Okay, I'll give some value, EMP-hyphen department name equal to something, and then what? EMP-hyphen employee designation equal to what? Manager. Okay, let me just print it. Employee number, then EMP-hyphen what? Employee name, then again EMP-hyphen department number, EMP-hyphen department name, and next EMP-hyphen what? Employee designation. So when I execute this, then I got the data: employee number, employee name, department number, department name, and what? Location. So here the output is not important. We are trying to understand the reusability. Reusability means instead of declaring the fields once again, I can include the existing structure in the other structure, and that existing structure can be a local or what? Global. Right? So any questions here? Done. Okay, so this is your what? This is your including the structure. 1 second, please. Okay. Done. So this is about the included structures. So we understood how to declare the structure. How to declare by using what? Data, begin and what? End of syntax. Okay. There is another way of declaring the structure, which is the recommended way. Okay. So yesterday what we have done, we are declaring the structure something like this: data, begin of, structure name, field 1, field 2, n number of fields. Okay, and we have seen how to copy the data within two structures. We understood the limitation of using what? Move corresponding. And just now we have seen nested structure and what? Including the structures. Okay. Now let us see standard syntax for declaring what? Structure. Okay. So far we are using data, begin of and end of. Okay. Now the recommended way, or in most of the projects, the structure, I mean to say structure is also called as what? Work area. Okay, it is declared by using this syntax. What is the first step here? Create the types declaration with the required fields. So let me do that. So now onwards, we will be following this syntax only. Standard syntax for declaring the structures. Done. So what is that first step you have to do? We need to create the types declaration with the required field. So first of all, what you have to do? whenever you want to create a structure, we should have an idea what fields you have to declare, what data types you have to give, what field names you have to give. Okay, so based on that only we'll create the structure. Okay, so what I'll do here, I'll say types. Okay, I'm using what keyword? Types keyword. So far, for declaring the variables or for declaring the structure, I'm using what? Data keyword. Now I'm using what? Types keyword. So types begin off. Okay, begin off. What is this type name? Type name. I can give any name. Let me directly give EMP. But already we know it is recommend we need to follow what? Coding standards. Just like parameter variable, we are starting with what? P underscore. Okay, variables we are starting with V underscore. Similarly, types declaration I will start with what? TY underscore. Okay, in some projects, they may start with what? T underscore. Again, depends on project to project. We need to check the manual related to coding standards, and based on that, we need to develop the code. So I'll say types begin off. I'll go for what? TY underscore, any meaningful name. So since I want employee fields, I'll give the type name as a TY underscore EMP. Let me declare the fields. Employee number type I, then what? Employee name of 20, type C. Then I'll declare another field, employee designation of something, 15, type what? C, type C. And I'll close this. End of what? Type name. What is the type name I gave? TY underscore EMP. Done. So if you, instead of declaring by using types keyword, if I use data keyword, what happens? Memory will be allocated and all these structure fields are stored one after the other. That is if you are using what? Data keyword. Data keyword will allocate the memory. But types keyword will not allocate any memory. Okay, types keyword, it just defines this particular data type. So types keyword is used for creating user defined data type. Okay, so far we are working with what? Standard data types, integer, character, string, all those things comes under what? Standard data types. Similarly, if you want to create your own data type, user defined data type, we use what keyword? Types keyword. So by using this types keyword, I created a user defined data type. What is the name of that? TY underscore EMP, which can accommodate how many fields? 3 fields. Done. And this types keyword will only provide the template. Types keyword will only provide the template. It doesn't allocate any memory. It doesn't allocate any memory. So if the memory is not allocated, I cannot store the data. Na? So how do we check whether the memory is allocated or not? Now what I'll do, assume this is declared by using data keyword. Okay, if you declare by using data keyword, I can directly access. Na? So I'll try to say here TY underscore EMP hyphen, what is the field name? Employee number equal to, I'll say something 1. This is very much valid if you declare the same thing by using what? Data keyword. So if I declare by using data keyword, it is considered as what? Structure. And how do we access the structure fields? By using what? Structure name hyphen field name. So when I do syntax check, right, I don't have any errors because the memory is allocated. I can assign the data, but I'll declare this by using what? Types keyword. Types keyword will only provide the template, will only tell you what are the field names, what is the sequence of the fields, what is the data type of the field. So when I do syntax check, right, I'm getting an error now. What is that? The field ty underscore emp hyphen employee number is unknown. Okay, the field ty underscore emp hyphen employee number is unknown. So I cannot assign the data because memory will not be allocated. So this is going to give me what? Syntax error. Okay, it is giving me what? Syntax error. So how do we access those types declaration now? This I'm calling it as what? Types declaration. Nothing but a structure. Anything which is a collection of fields is nothing but what? Structure. But in this case, memory is not allocated because we are declaring by using what? Types keyword. So how do we make use of this structure now? How do we make use of this types declaration? We need to create instance of this template. We need to create a variable based on this particular types declaration. How do we do it? Now I'll use what? Data keyword. Okay, data keyword. I need to give the structure name. So I'll give the structure name as something what? Generally, you'll structure is nothing but what? Work area. You'll start the work area with what? WA. Okay, also data W underscore EMP1, some name. Any name I can give. Simply I can say XYZ also, doesn't matter. But in general, the structures, the work areas, you'll start with what keyword? WA. In some projects, they must start with LS to indicate that is a local structure. In some projects, they must start with what? GS to indicate that is a global structure. Okay, so according to the project coding standards, we have to use the appropriate naming conventions. I'll go for what? WA underscore some meaningful name, EMP1 type. What is the type name now? TY underscore EMP. So also type TY underscore EMP. Now the memory is allocated because I'm using what keyword? Data keyword. Okay, so this will only provide the template. It only provides a structure. Based on the template, we are instantiating, means I am creating a variable. Now the memory is allocated. How much memory is allocated depends on the fields in your types declaration. So employee number is 4 bytes, this is 20 bytes, this is 15 bytes. All the fields are stored one after the other. So once you declare the structure, I can start accessing that. Employee number is equal to something, then W underscore EMP1 hyphen employee name equal to something Raju. W underscore EMP1 hyphen employee designation equal to something. Okay, done. Understood. Then let me print it. Right. For our understanding, I'll just give a string here. W underscore EMP1 structure. Whatever you give in single quotes will be displayed as it is. Okay. Let me print the fields. How do we access the fields? W underscore EMP1 hyphen employee number. W underscore EMP1 hyphen employee name. Okay. W underscore EMP1 hyphen employee designation. So save it, check for the syntax, done. When I execute, yes, I got the data. So this is a standard way for declaring the structure. What is the standard way? You create the types declaration with the required fields. Create the types declaration with the required fields. Based on the types declaration, based on the template, you can create any number of work areas. I mean to say structures. Okay, this is one structure. Now similarly, I'll create another structure, data W underscore EMP2 type what? TY underscore EMP, means based on the same template, based on the same types declaration, I can create n number of work areas. So I'm trying to create one more work area. So let me just print it now. So as of now, you will have a default values. Okay, so let me just say uline, underline, right? I'm creating one more work area structure based on your type declaration. Okay, so here I'll just print it, emp2 hyphen employee number employee name. As of now, not assigned any data, so obviously you'll get what? Default values, zeros and what? Spaces. So what I'm trying to show is, once a template is available, I can create what? Any number of instances. I mean to say, I can create any number of work areas, variables. Now I'll say, already we know this. What is that? W underscore EMP2. I'm assigning W underscore EMP1. Okay, let me print it now. W underscore EMP2 structure after assigning what? W underscore EMP1. Some message. Let me print it now. So when I execute, both are what? Similar. Both are created based on what? Same types declaration. So the number of fields, the sequence of fields, the data type of the fields, everything is what? Same. So when I execute, I'll get the data 6 Raju and what? Director. Okay, so now onwards, I'll create the structure like this, because this is the recommended way for creating structure in most of the projects. Okay, still in many projects still people are using this syntax also. Fine, no problem. Project to project we have to check the syntax, we have to check the guidelines, and we have to declare them. But this is the recommended way. Once you create the template, based on the template I can create any number of instances. I mean to say any number of variables, any number of structures. Okay, any questions, please ask. Any questions? Done. Okay, so we understood the basic concept related to what structures. So I summarize everything. When do we go for structures? Whenever you want to store some interrelated data, okay, we'll go for what structures. That is, whenever you want to store a record kind of information, we'll go for what structures. Okay, like employee data, customer data, vendor data, material data. So all this data would be what interrelated. All this data will be interrelated. Okay, so in those cases we'll go for what structures. And we have seen how to copy the data between what two structures. Okay, but that is by using assignment operator and by using what move statement. And we understood that both assignment operator and move statement is what same. And we have seen move corresponding also. Okay, move corresponding, what it I can use assignment and move statement only when the corresponding data types between the two structures are what same. If one of the data type is not matching, it will give a syntax error. And move corresponding, we understood what it will do. Move corresponding will check for what matching field names. It doesn't check for what data type. It doesn't check for any sequence. And we understood the limitation of what move corresponding. What is the limitation? It will decrease the performance. Why it will decrease the performance? When you're copying the data between two structures, what happens internally? Each field of the source structure will be compared with what all the fields of what target structure. Okay, this comparison will be what time consuming. Okay, this comparison will be time consuming, so obviously it will degrade the performance. What is the other limitation of move corresponding? When you are using move corresponding, it only checks for what matching field names. It doesn't check for the data types of those fields. So if the data types are not type compatible, it may lead to what runtime error. So every time it will not lead to runtime error. Whenever the data types are not type compatible, it will lead to what runtime error. That is the reason it is recommended to minimize the usage of what move corresponding. And today we are seeing nested structure, declaring the structure inside another structure. Okay, so in that case, what is the focus? How do we access the inner structure fields? We need to refer outer structure hyphen inner structure hyphen field name. And we are seeing including the structures. How do we include one structure inside what another structure? Okay, that is done by using what keyword? Include structure. By using that include structure keyword, I can include a local structure or a global structure. Local structure means a structure which is declared in the current object, current program. Global structure means which is available in the database. What is the default behavior? First it will check whether the included structure is available in the locally within the program. If it is not available within the program, it checks whether that is available in the database. If it is not available in the database also, it will give a syntax error. Then we have seen the standard way of declaring the structure. What is the standard way? First we need to create the types declaration with the required fields. Types declaration allows us to create what our own data type, user defined data type. It only provides a template of the fields, doesn't allocate any memory. So once a template is available, I can create any number of instances, any number of variables based on that particular types declaration. Okay, and we have seen how to declare and how to access the fields. Right. Now let us go to another small concept, field symbols. Right. So just try to understand how do we declare the normal variables. If you want to declare integer, character, or any other data type, we'll use what keyword? Data keyword. Okay. So let me say data x type I. How do we initialize it? By using the keyword what? Value. Value I'll give something what? 10. So I'm declaring the variable as well as initializing the variable. Then I'll declare one special variable called as field symbol variable. How do we declare the field symbol variable? We have to use the keyword what? Field symbols. Okay. I'll give the field symbol name as ABC. Okay, so what is the field symbol variable name I am giving? ABC. This is my normal integer variable. This is my field symbol variable. Let me check whether I'll get any syntax error. When I do syntax check, yes, I got an error. Field symbol names must begin with less than and end with what? Greater than. Okay, so if you declare like this, it seems that this is not valid. So this is giving me what? Syntax error. Okay, so how do you declare now? It seems that you have to start with what? Less than and end with what? Greater than. So what is the meaning? Field symbol variable is always enclosed in what? Angular brackets. Done. Now let me try to print the value of x and y. So I'll say, for your information, I'll say x is, what is the variable name? X. Or generally how do you declare the variables? V underscore. V underscore. So let me follow that standard. Okay, so v underscore x is v underscore x. Done. And in the next line I'll try to print the field symbol variable also. What is that? ABC, single quotes, ABC is, okay, ABC is, what is the variable name? ABC. So in case of field symbol, I have not assigned any data so far. So when I do syntax check, I don't have any errors. When I execute, yes, v underscore x is, what is the initial value I gave? 10. ABC is having nothing. As of now, nothing is there in the ABC. So you can observe this while declaring the field symbol variable. Did I mention any data type? No. So a field symbol variable is capable of storing any kind of data. It can store integer, character, date, whatever it is. I can store any kind of data. So how do we store here? Now I want to store x value inside what? ABC. So generally, how do we assign a variable to another variable? You will say what? Something like this. You will say something like this. Understood? We are assigning x to what? ABC. Understood? This is the way you assign the one variable to another variable. Let me check what happens here. Save, check it. I don't have any syntax errors. I'll activate this. Okay, let me try to execute. When I try to execute, I got a runtime error. What is the runtime error? Assignment error. Assignment error. Field symbol ABC was to assign a new value, but this field is at least partly protected against changes. So if you scroll down, what is the line which is leading to runtime error? The screen is called as what? Runtime error. So if you scroll down, yeah, this is the 10th line where it is leading to what? Runtime error. So what you have to understand is, whenever you are assigning a variable to the field symbol, we should not use assignment operator. So if I use like this, what is that I am getting? Runtime error. Understood? When you're practicing, you uncomment and practice. Then only you'll get the runtime error. Okay. So what you have to do? We have to use what keyword? Assign keyword. I'll say assign v underscore x2. What is the field symbol variable name? ABC. Let me print it now. I'll reprint it again. Done. So I assigned that. I assign is a keyword you have to use. When I execute, yes, I got v underscore x as 10. ABC is also what? 10. So once we assign a variable to the field symbol, this is called as referenced variable. Once we assign a variable to the field symbol, we call this as a referenced variable. Once we assign, a link will be established between these two variables. A link will be established between this referenced variable and what? Field symbol variable. So once a link is maintained, any changes made to the data of one variable will automatically reflect what? Other variable. Suppose now I'll say v underscore x equal to 20. I'm just changing the value of what? X. I'm not changing the value of ABC. What is the previous value assigned to ABC earlier? 10. We are assigning X. When X was 10, I assigned that. Now I'm changing that X value. Let me check whether it will reflect both or not. I'm not reassigning. Once you assign, a link will be established. So when I execute now, see, when I execute, done, what I got, v underscore x is 20, abc is also what, 20. Let me do reverse. I'll say abc is equal to 30. Let me print it now. I'm changing field symbol variable. Okay, so when I execute this, done, I got what, 30 and what, 30. So what is the understanding? Once we assign a variable to the field symbol, a link will be established between that variable, that reference variable and what, field symbol, so that any changes made to the data of one variable will automatically reflect what, other variable. And I already told, a field symbol is capable of storing what, any data. As of now, what value we have assigned, integer na? Now within the same context, within the same program, let me declare one character here, or let me declare one string. I'll say v underscore str type string. I'll say value gens of technologies. Okay, so this time I'll assign the v underscore str value. How do we assign v underscore str to same field symbol? Understood? While declaring field symbol, I have not assigned, I should not specify any data type. It is capable of storing any kind of what, data. So I'm assigning now. Let me print it now. So the link is established between what now, str and abc, means the link is broken between x and abc now. It will point to what, str now. Let me try to print all these three values. V underscore x I'll print. I'll also print what, string also. What is this? V underscore str is V underscore str. Okay, let me execute now. Yeah, what happened? X remains 30. What is the last value of x? 30. ABC is what now? Gens of technologies. STR is obviously what? Gens of technologies. Means into the same field symbol variable, I am able to store a variable of different data type. Initially, I have assigned integer. Now I am assigning what? String. Understood? So the link is broken between the earlier two variables. Now the link is established between str and what? ABC. Now I'll change the value of str. I'll say v underscore str is equal to, I'll say something gens of systems. Okay, let me say uline, right? So I'm changing the value of str now. I'll reprint all the three now. What happened now? X remains 30. X remains 30. ABC is changed to gens of system. str is changed to a gens of system. Okay, so this is one of the purpose of field symbol. Okay, going forward we'll be using this field symbol in many places. So what is a field symbol? It is a special data structure. It is a special variable which is capable of storing any kind of data. A field symbol variable must always be enclosed in what, angular brackets, and it is declared by using what keyword? Field symbols keyword. Whenever you want to assign a variable value to the field symbol, we must use what, assign keyword. Once a variable is assigned to the field symbol, a pointer link will be established between the variable and what, field symbol. So any changes made to either of the variables will reflect what, both the variable values. Understood? So this is the points. These are some of the basic points related to what, field symbols. We will be using this field symbol in different ways going forward. This is only the basic syntax. Any questions, please ask. Done. So we are done with the structures and all the basic things. Tomorrow onwards, we'll be starting either with internal tables or with dictionary objects. Okay, I'll be starting with either of these two topics, either internal tables or dictionary structures. I'll decide that tomorrow only. Okay, right? Internal tables or dictionary objects, I'll start from tomorrow onwards. Any questions for today? Okay, so Chera then shall wind off. We'll continue tomorrow.